Here we go. We're being recorded. This is Design 350. It's the lecture. It's from Thursday, November 5th. And what we're going to do today is sort of culminate what we've been doing with the survey and turn it into how an actual survey transit works, which is taking those distances and angles and then getting a rod reading for the elevation. So that's the last part. This unit is due on Sunday. And really, you're just going to be presenting the work that you've done so far. I haven't added any of the extras. So it's all going to be on this site. I would like you to just read what's in there and follow along. I think if you have questions, just ask me. But really, it's being able to present property lines and sections based on these survey readings. One set of survey readings are XY. The other are YZ along a given traverse. So one gives you a property, the other gives you a section of elevations. And then what we're doing today is we're getting X, Y, and Z essentially. We're getting position and elevation on the boundary again. So if you want to take this style, this regular survey style, surveyor's units and all that kind of stuff, and do more, you can go on with one of the optional modules. And the game is pretty well developed now. We're getting better and better. There's a few more things to do. There are some outputs that will go directly from the thing. There's some adding rods and removing rods and some airplane views. But overall, it's set to be able to do its job. So let's see what we're doing today. So Sunday, this unit is due. Turn it in. You will have an opportunity to get feedback and do any revisions because it's not, this one hasn't been as nailed down and clear as some of the others. So I want you to just turn in your good work. I want the DWGs, the PDFs, and the template. And for those of you who turned stuff in last week, to get the pre-check, you'll know what I'm talking about. So everybody else should send you a Starbucks gift card, and you can clue them into what you did before. It's really important to get your pre-checks in. That's where I really give the feedback. And if you didn't do that, if you didn't turn anything in, you're just going to have to do the best you can on this one. But I'll give you a little feedback and let you turn it in again if you want. Okay. But that's extra work for me, extra work for the boss. Bosses never like extra work if they can help it. So do your best in the future to get your pre-checks in on time so that I can pre-check when I plan and want to pre-check, not at a different time. Okay, so here we go. We're gonna continue using a survey transit level. And we did that last time on Tuesday by using a distance and an angle. But now we're going to find the Z reading, the elevation, and we're going to subtract a rod reading from an instrument's height. So let's see how that works. Here's an example of it. Okay, and I'm going to see if I can zoom in a little bit. There, that let me zoom in a touch so you can see it. So this is a setup. Okay, here's your survey unit, your transit, and you look in one side, and it scopes out in a perfectly straight line because you made this level. That's why they often call it a level. And so that straight line of sight hits the rod, and you read how far it is from your line of sight to the ground. So that way, if you know that this is at 20 feet, and you know you go down 5 feet, well, then that is pretty obviously at an elevation of 15 feet. That's how it works. That's how simple it is. You know the elevation of your line of sight, and you read how far it is down to the ground. And your rod reading tells you that. And your instrument height minus your rod reading is your ground elevation. So the trick is, how do I find this number? How do I find that? Well, that's done using something called a backsight reading, where again, you have a rod and you go down. We're going to go, this says a known elevation. We're going to say that that known elevation is 0. Just to make life easy. So now whatever my rod reads when I set it on my 0 point, well, that's my backsight reading is my elevation. And we'll have an opportunity to get more complex with that, but we don't need to. So that's how it works. And here it is all kind of jumbled up with height of instrument, and here's where you would actually, did I turn on my recording? I think I did. Yes. This is where you would actually write it. Okay? So again, let me make this a little bit bigger so that you can see it. So you take that backsight reading to give you the height of the instrument. And this is where you say what that backsight elevation, that standard elevation is. So you can see this elevation plus your rod reading is the height of your instrument in the true world. And then you find out where it is. Now, in our examples, we're just going to be using an X and a Y reading there. But you can also find out where it is. Okay? No, actually, that's in the game. We'll use an X and a Y. You can actually find out where it is. So you can draw that back to your 0 point. That lets you insert your drawing onto the project drawings at a known spot. But essentially, what are you going to do then? You're going to read your rod at each spot. We've already measured the angle and the distance, so now we have to read the rod. If my line of sight runs into the rod at 20 feet, then that means it's 20 feet down to the ground. So 27, if I read my rod at 7, it means it's 7 feet down to the rod, down to the ground. Okay, so if my line of sight is at 27 and I move down 7 more feet, the ground elevation is 20. Let's go down to this one. If my line of sight is at 27 and it runs into the rod and the rod says it's 2 feet down to the ground, then my elevation of the ground is 27 minus 2 is 25. Okay, let's take it over here. If my line of sight is at 27 feet and it runs into the rod 6 feet above the ground, that means I have to go down 6 feet to hit the ground. 27 minus 6 is 21. So that's how you get your elevations listed all around. Okay, and literally what I would do is I would just write my dot here. I would write station 1.02 has elevation of 21. That's how you read one of these things. So the trick is that while you take your data, you carefully identify what number you're talking about, what your readings are, and then what you calculate. Okay? Pretty cool and straightforward. Are there any questions on that? Does that kind of like make a lot of obvious sense? This is the one that really ties it all together. Okay, so I'm going to clear. Oh, that cleared too much. Let's see if I can erase that. So there's a question. Kara asks, is there a way to set 0, 0 east in AutoCAD? Yes, and I'll go over that. We did that last week, and this is where I suggested that you guys actually take notes and post them that says, okay, in the video, this was important, and people could go back and see it. But I'll go back and do that one because it is kind of important. So here I am. Okay, if I type in units, this comes up. Or I can go to my A and go to units. This comes up, and it's under direction. So remember, the first thing I want to do is say my piece of equipment walks clockwise, and then my direction, this is where you set it, east is 0. But you can change it around. You can say north, base angle is north, or something else. Okay, but it's set for east is 0. You can say some other angle is 0. Okay, so that's where that is. So I'm going to go back and fix that up again now. Put it back where it belongs. But it's easiest for us to just use what's commonly there, which is east as 0. And remember, we better make sure it says clockwise for what we're doing. Let's see. Laura says, how do we know which number we are reading? I don't know what that means. Do you need to share your screen so that you know? How do you know which number we are reading? Oh, back in my example. Okay, let me go back to here in this example. So in this example, everything that's looking forward, it's called a foresight. The only one that's a backsight is when you actually put the rod on your known 0 point. Okay, so when we come over to here, the only one that's a backsight is where the surveyor says, go put the rod on my 0, 0 point. That's the only one that you know. And then you read your distance and your angle. Now, I've given it to you. Oh, the station number? I did. Yeah, I gave you this actual form all filled out except for this. So I gave you this form without this column and without this column. So now what you're going to get is, here's a sample survey record for you to use. So here's one, and so you can see I've given you one that has most of it filled out. Well, now you have to know to put a 27 in there all the way down. And then you have to know how to calculate this. 27 minus 7, 20. So I'll do this first one. That has to equal whatever my instrument height is. And that has to equal my height of my instrument minus my rod reading, 20. That's all you do on this one. And then you go and draw it. Okay? Because this is actually what a survey record would look like before it's all calculated out. This is what you would be doing out in the field. Now, the best surveyors do this as they go along to see if they're getting numbers that sort of look right. They're looking around and they're going, hey, I just got something that said 45 feet and it should have gone down. What's going on? So then they know that they wrote something down wrong. So good surveyors are doing this as they go, but you don't have to worry about that. You've been given a survey. You've got this information. You've got the stations. You've got the rod reading. Now look, these do not match the game. This is a practice one for you to do. And I'm just going to do some of these to show you, and then I'm going to teach you the new version of the game. So watch. This is really easy. Pay special the value. There we go. And if I want to make it look like I'm really precise, I add some. And then this equals that number minus that number. And I can just carry it down. So that's how quick and easy that is. So now I'm going to go for each one of these rod readings. I'm going to draw my distance, my angle, and my height. Okay, so I'm going to take a picture of this really quick. And I'm going to pop that into AutoCAD. And I'm going to make sure I've got all my units right. Now remember, I'm doing unitless. I've been told that everything is in feet, by the way. Okay, clockwise. Direction east is 0. Okay. I'm just going to draw something. Let's see. Where was my... I'm going to put a circle at my point there. Let's see. That was on my snip. I didn't take my snip, so I need... There we go. Okay, so my backsight, watch. I'm going to draw my backsight first. Okay. So my 0, 0 point is from here to here. So that's a backsight. So let me draw that one. I actually need my snip to pick that. Oh, I did pick it up in my snip, so I can put that in. So I'm going to just try that. I'm going to start anywhere. I can start literally anywhere. So I'm going to start on 0, 0, 0. I got that stupid dynamic thing on that I was telling you guys about. 0, 0, 0. And I'm going to go 549.66, 549.66, at an angle of 118.58 or 68. 18.68. And it's from where I'm at. Cool. So that sort of gives me a little bit of an idea of how big things are and where they are. So now I can start drawing. Now, I can also go put this point now on my 0, 0. So I'm going to move. There. So that's how I set up. Okay, and what did I just draw? I just drew this one right here. Here, here. And guess what? I'm going to put a little annotation right there that says that's at 27. Okay, and that's my station 1. Okay, now I'm ready to go. Now I haven't done my layers and all that other kind of stuff, but I should be okay. So now my first one from there, pretty simple. Now you should have this drawing done already, as a matter of fact, but I'm going to say from where I'm at, 399 at an angle of 58.91. So I draw it. And then I like to put my point there right away, and that's 1.01 at an elevation of 20. So I just go along and start putting things in. One thing at a time. So what's my next one then? It's at 433.89. Let me zoom in a little bit so I can see better. At an angle of 64.31. And it's got an elevation of 21. So I'll draw from where I'm at. 433.89 at an angle of 64.31. And then I'm going to note my information right now. So this is my station 1.02. And it's got an elevation of 21. You're right. You would not want to do it twice. Okay, so let's see. Station number, I say, got it, thanks, makes sense. You wouldn't. Okay, I think I've caught all of the chat. So that's essentially, oopsie, what you do. Now these should be on proper levels. Do you guys know how to do an attribute? If you want, you can put this in as an attribute, because then you can export it very easily. We're not going to do that right now. If you do the survey optional unit, I'll teach you how to put those in as attributes so that you can export them very, very, very easily. You can export the XYZ coordinates. You can do the angle and distance coordinates. You can export the station number and the elevation, all of that kind of stuff. So Natalia says, if you did the drawing on Tuesday, all you need to do is add the elevations. That is absolutely correct. All you have to do is add in that portion of it. Okay? Which is why we like to have the survey records so that you can go back and do them well and do them properly. Okay? So yeah, that's the idea. And that was the goal of doing this step by step. I think that if I tried to teach you all of this in one step, it would be like the teacher on Charlie Brown. Wah, 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 wah. That's what you guys would hear. And I think this way, oh, I got it. All I got to do is add the elevations now. Now, one thing that's really cool, if you want to do this in 3D, and again, this is not part of this, but you'll learn how to do this if you do more. If I click on this line and look at the properties, what do I know about that line? I know that it started at a height of 27, so I could put my start Z at 27 and my end Z at 20. So now very quickly, I'm creating a 3D from this, right? When I drew this line, I started at my instrument, which had a height of 27, and I drew out to the boundary point, which had a height of 20. And AutoCAD allows you, every single line in AutoCAD, you can set all of the starting and ending XYZ positions. So I drew it, and this is so cool. But look, it tells me the length and the angle, so I can go back and check. 399.06 and 58.91. There's my angle. It's really, really cool. Okay, so I could, if I wanted to, turn this into a 3D thing and export it right to Revit, and it would draw my topography for me. So again, there is so much more that we could do with this if you feel like it, but this will be in the optional modules. You may go, I've got everything I need. I know how to do this. I can take a laser and I can take my wheelie thing and I know how to do everything I need to know. And you can work on other aspects of land planning and stuff. How do you do the 3D with Revit? Okay, I'm going to show you a really cool thing now. So let's see. This one has an output start of 27 and an end of 21. And this one has a start of 27 and an end of 22. Oh, no. This one has a start of 0 and an end of, I don't know what I've got going on there. Let's see. Oh, that's my transit one. Let me do one more just so that you can see it. And go from there, from where I'm at, 428.67 at an angle of 69.06. 69.06. Then I'm going to copy this information. So that becomes 1.03. And its elevation is 22. So then I need to take this one and tell it that its start was at 27 and its end was at 22. There we go. Okay. Now there's a very interesting function called export. So I'm going to go to my thing here. Oops, got the wrong one there. And I'm going to extract some data. So this thing has to get saved. And this is going to be data extract sample. There we go. Okay, so I'm going to create a new extraction. It says, where do you want to put the rules? The first thing I'm going to do is set up the rules to tell AutoCAD what to get out of here. So I'm going to call this one sample extract on 11/5/20. And then it says, what do you want to extract? So I can extract the whole drawing, or I can get just those 3 lines. Okay, you're going to take the lines. Now I could also take, if I had formatted this text right, I could get all the text or attributes and things like that. I only want to talk about the geometry. I'm going to clear all. And what do I want to know about this? Well, let's say I want to know the end positions. End X, end Y, and end Z of each of those lines. And then I get to uncheck all. And does that look, X, Y, Z, does that sort of look like what you would export to Revit? So for us, you'd want to extract the whole drawing. Now, it depends on what you want to do in Revit. You would probably just do the 15 points at the end of your survey lines. But we'll go over that later. What I wanted to show you is that look how quickly and easily I can get my survey points right out of here. Now, of course, since you already took them, there's another way to get this. So I'm going to go put these someplace. I'm going to show you another tool that I made for you that I think I gave you a thing to. Survey data. There we go. So that just extracted the data. Okay. But of course, you could translate all of these into X, Y, Z data. Didn't I give you the translator? Maybe not. Let me go find that for you guys. I think I gave it to you, but now I have to find it. Well, now I don't know where it is. Oh, that's no one. Okay, let's see. Oh yeah, there it is. Thank you, Benjamin. I knew it was somewhere. So look, if you know the distance and the clockwise direction, you can get X and Y. Counterclockwise. And if you know the distance and the clockwise direction, you can get it. Okay? So if you wanted to, you could pop those numbers right into here, and it would give you an XY calculation. Okay? Yeah. So let's say, well, yeah, it's called Excel. It's such a cool thing. So let's say I've got this. If I've got a distance of 399 at a, oh, this is clockwise, 399 at an angle of 58.91, that gives you the X and the Y from your start point. From your start point. Okay? X and Y from your start point. So you could convert this, but tell you the truth, mostly you're probably going to want to just draw it out. I just put this in there because it's kind of cool. I like the fact that I can extract this data and get my X, Y, Z points, and then I just make a topography out of those. Yeah, Excel. So Benjamin says you can do anything with Excel. I'm going to show you what you can do. Check this out. If you go up to this function tab, these are all the functions that it automatically calculates for you. I use this all the flipping time. Look at all the things it'll actually do. Look, it'll even call Google Translate for you and translate a word. It's like, man, hypergeometric distribution probability. Good grief. Imaginary numbers. Man. Hyperbolic tangent. Good. I'm only to the eyes, right? Large, what does that do? Nth large element from a data set. I don't even know what that does. Look at all the things that you can do. So we program in this, data, graphs, calculations, you name it. Quartiles, random arrays. You can create a random array of numbers, a grid of numbers to use for just practicing things. If statements, sums, substitute this for that, tons of text stuff. So yes, tons and tons and tons of stuff. Oh yeah, pivot tables. They've got all sorts of cool pivot table stuff. You can even, check this out, you can create, is it here? Hold on a sec. Data tools. You can even write your own programs in a language called Google Script, which is essentially JavaScript. And you can make buttons that do complex calculations or complex operations for you. And you can actually program it yourself right inside of this. So instead of just saying this cell equals this, you can go get data. You can do all sorts of cool. Yeah. In the Design Hub, we use Google Scripts a lot. Anyway, so let's go back to finding the Z reading. So that's how we did it. I did the Jamboard. Here's that. Here's the sample survey record for you. So your job is to just go through and calculate that HI value, which is easy. I gave it to you. And then just calculate the elevation and add donuts to your property. Okay. And then if you want to, you can take that drawing and put it into Revit. Now, the other way that you can put it into Revit is once these are at elevation, you can actually draw point to point to point all the way around. And then you can copy that drawing, or you can insert that drawing into Revit. And that's like making a topography from a DXF. Okay, so you would put these lines in once you've got your property, and you can put that right into Revit, and you can get your topography that way. Uh-huh. Yep. Yep. How'd those come out? Really? How did that happen? You used the same data. Did you guys start at the same place? Okay. How different was it? Oh, okay. That's somebody put a reading in wrong. That's all. Okay, so that's not so bad. Yep. Yep. No. Do the elevations on the one that matches this data exactly. Yeah. Yeah, if you had now look, it could be that I took a couple of different data points or whatever. I mean, if it was way off, but if it was pretty close, you don't have to correct anything. You can just use this data. That was just an exercise to show that what you need to do is really go in and check. Look at how many places there are to make a mistake. You could swap two numbers. You could get 19. You could type accidentally 56.9. I mean, it is so easy when you have all of this data to make a mistake, right? So that's all that was for, was just to show that it's really, really hard to get all these exact. For the purposes of today, take the drawing that you made on Tuesday, that you made from this data, and just add the new elevation, calculated elevations, right? Just take the new calculated elevations and type them in. That's all I really want you to do, okay? Now, I'm going to take just a minute and show you what the lab is, because we've got a new game, all right? So let's see. That's all that. Okay. So that's all that. And if you can get it into Revit, that's really good. That's an extra additional cool thing, right? That's for those that just want to do extra cool work. All right. So now, let's take a look and see what the new game is. Okay? So now, you're going to actually get to look through a transit level. Okay? While you're in the game, if you press V, it turns the scope on. And if you press V again, it turns the scope off. So you'll be standing there looking around. You go, okay, I'm ready to look through my scope. And you press V, and all of a sudden you're looking through the scope. If you press plus, it zooms the scope, minus zooms out, and 0 resets it. So V, plus, minus, and 0. So you can look through the scope. When you look through the scope, you're going to see that the scope is going to tell you the X, Y, and Z position of the scope. So Z becomes the height of your instrument. When you look through the scope, right below the scope, it says, I'm positioned at X, Y, Z. Right? And I did that on purpose to make it easier than trying to do the backsight and all that other kind of stuff. We'll do that later if you go on. Okay? And then there's 3 boxes that you see in the scope. One is the rod reading, one is the distance to the rod, and one is the angle that you've turned to see the rod. So the scope, 0 on the scope is pointing due east. And then you just read your scope angle reading to get the angle and the distance. So here's a little video of it that you can watch. That's what you're going to see. Isn't that cool what you're going to be able to see? But here's the actual link to the game. Uh-oh. What happened? Did I do a bad job on the link to the game? Well, that doesn't work. Hold on a sec. That's better. So this is how you play the game. That's exactly what it is. That is so Benjamin says looks like a rifle scope. That is exactly the company that makes the best scopes. They make them for the rifles too. And the 2 little crosshairs, let's take a look really quick. So if I'm going to press V, you see the main scope. Okay, that's your line of sight. And those 2 up and down are called your stadia lines. And if you were actually reading a rod, that would actually let you figure out your distance. Because those are like plus and minus 0.1 degrees off. And so you could do a little bit of geometry and figure out that if you measure, 4 inches at such and such degrees apart, then you know the actual distance. Okay, and you can see right now there's no rod, but you see down below where it says the scope location, and you can see what my angle is reading as I turn. Okay, so now to do my job, I'm going to press V to get out of this. I have to go put a rod down somewhere. So let me find, and you can see I've also got the ground is a little bit easier to see now. Kind of nice. I'm going to put a rod right down here in this low point. And I can still get my XYZ coordinates. Those are the XYZ coordinates. I can do that. But now if I press V, I'm looking through my scope, which is somewhere out in the middle of this thing. Okay, and so now I'm going to start spinning around, spinning around. Oh, there's the rod. I just found it. And when I'm centered on the rod, my numbers come up. And it can be pretty hard. There it goes. And I'm going to press the plus button. I'm zooming in on it. So I'm seeing the rod. Now I'm going to press my minus button. But my distance to the rod is 294.8. My angle, I've twisted my sight through 62 degrees, and my rod reading is 46.9. So this is reading the rod. It's 46.9 from my height of my instrument, my level sight, down to the ground. 46.9. So Z is 80 for my instrument height. Do you see the 80? 80 minus 46.9 is my actual elevation of the ground at that point. Okay? So that's how you're gonna do this one. And again, I'm gonna let you work in teams. You could do it on your own too if you want. If you want to just do this on your own, that's okay. But it's really good to be able to work in teams. My suggestion is that you guys pick good points. So I'm going to press V again. I would not pick that. Well, you could run a traverse. Now, I don't have a way to take a rod off yet, but I might walk around the outside. Where's my outside? Here we go. And redo this thing. I'm looking for a corner. Here we go. So I can start here, and I know that there's going to be a rod. That looks like a good spot right there. And now I can go to my next spot, and I would put, looks like I'm a fairly even slope up to here, and then something happens. And I would get good at kind of picking where you're going to put your rods all the way around. And I would place however many rods you think you're going to need to get a good survey. This is sort of your ultimate on this. That looks like I might need one there. And so you might have 25 or 30 rods. You decide how many rods you want to get a good survey around this thing. And then you can go and run. Well, I just want you to get something actually. But it shouldn't take you too long to get these rods down. And see how I'm picking kind of points where it looks like things are changing? Everywhere I see kind of a major change, I'm putting these down. Because I want a really good survey. This is sort of your ultimate. I'm getting probably a few too many, but I don't care. I'm going to practice. Actually, I'm going to have you practice. Okay, so you get the idea? And then you're going to go into your V. I'll probably start at 0, which is due east. Okay, so there's 0. I'm going to start there, and then I'm going to just start taking them around. Come on, I know I can get it. There we go. There we go. So that's going to be my 1.01. 256.3 at 5 degrees with a rod reading of 14. Click. Go get my next one. Oh, there it was. 275.9, 30 degrees, 34 rod reading. Okay. So some good questions. Let's see. Would it behoove us to do one rod at a time? You could, but you're just going to go around and really, it doesn't really even matter if you get them all in a row, so long as you're just going to go around, and if you see that they're all increasing and that they're looking pretty good where you put them, there's 30 degrees again. You're going to hit them one at a time as you go around. So personally, I think I would go put them all around and then do it. And then how do you know which rod is which if you lay a bunch of them down? You're just gonna give them a name in order that you see them. The number is just so that you can refer to it later on if you need to do something. Okay? This is kind of nice because you are going to get them in order of angle as you go around. Okay, as you go. Now, one of these is kind of like this front one is probably that one on the traverse that I don't want. So there's that one. So I would not put the traverses down. I would go back in and do the game separately for each traverse. Okay, now, how long would it take you to really do this thing? If I were assigning this, I'd probably give you 2 3-hour lab periods to actually go out and walk this site and plop these down and get your numbers and all this kind of stuff. You're getting 1 lab period and then whatever extra time you need. I'm expecting that this exercise could take you as much as 3 hours. Okay? And so just do the best you can. The most important is that you have, even if you only have, let's say you get 10 of the rod readings done. Okay? Get that done well. And all I'm asking you to do is draw your 2D drawing, but note the elevation with text at each point that you take. And you don't have to take as many points as I did either, right? If you want to just find corner points where there's like 15 of them, you can do that. Yeah, and Renolfo, there are 4 traverses, correct? Yes, there are, but I'm asking you to do the property line. The traverse is totally extra and optional, and it's the type of thing that I'm going to ask you to do in the optional survey module should you wish to do more. Okay, for this assignment, let's see what this assignment says. Okay, so place rods strategically around the boundary. That's what I'm asking you to do. So it's your choice what strategically means. Your strategy might be minimize work, and you'll put 4 of them down, and you'll have 4 points. It might be catch the corner points, and then I think there's 15 places where it actually turns a corner. Or it might be I want to get the boundary as closely identified with all the elevation changes as I want, and you're probably going to take 35 or 40. Your choice. It says strategically, and I have not specified what your strategic goal is. Woohoo! Okay, so then go to survey mode, note the XYZ, and that's just to get it down on your survey record. and then start at 0, 0, start turning slowly clockwise, take the reading. Now, what I like to do is actually put this thing down on a Jamboard and start noting it down, because you do have a drawing of this, and you can sort of start noting it down on a Jamboard if you want, but you don't have to. When you're done, share your readings, okay, draw the property lines and add the elevations as a double check. Now this, I'm not going to check to see that you did this. This is just if you have a chance, okay? Compare your drawing with somebody from your own team, and then compare it with somebody from another team. That's where it really gets cool, right? You guys should absolutely identically match within your own team, but if you go outside your team, you're going to see differences. And this is part of building up your understanding of how much work you should do on a survey to get the information that you want at the accuracy and precision to do the job that you want. Okay? Woo! Questions? Okay, here's the breakout sessions. I don't care who you work with. You can work with 2, 3, or 4 people if you want, or you can work alone and not go to a breakout session. So I'm going to turn all these on really quickly so that you guys have, I see that sometimes it doesn't let people in. So I'm going to turn them all on, and then I'm just going to let you guys work away, okay? Any other good questions? Okay, and when you go to a breakout, please log out of this one. Well, it doesn't really matter, but I'm going to use this meet again at 11 o'clock. Okay? Cool. There we go. I'm going to turn off the record.